So before investigating slope-intercept and point-slope forms of an equation, we have to refresh ourselves as to what slope exactly is. And so remember that slope is a measure of the ratio of a line's vertical movement to its horizontal movement. So if we have a line that's graphed like the one that we have here, so this blue line that's going to extend that direction and back this way, and we identify any 2 points that are on that line, we can calculate the slope by comparing the rise, the change between the y-coordinates of the 2 points. So in this case, that would be y2 minus y1, and then putting that in a ratio versus the run, so the change in the x-coordinates. And so we can go x2 minus x1 for that horizontal distance. And so what we can do is we can put those into a formula where slope equals exactly that. The difference between the y-coordinates divided by the difference between the x-coordinates. So that's known as our slope formula. And the order in which we do that subtraction does not matter as long as we're consistent. We could have gone y1 minus y2 over x1 minus x2. That would have been just fine too. And so in front of us here we can see a tool that we can use to kind of help us out in refreshing ourselves about kind of slope, when it's positive, when it's negative, when the slope is 0, and when the slope is undefined. So to start off with here, for a positive slope, so that's going to be the green in our face here, so the eyebrow is going up from left to right. So that's what we see here. The line is rising from left to right across the page, then that means we have a positive slope. And so for the line that we have in front of us here, we've got a rise of 1, a vertical move of 1, a run of 3, horizontal move of 3, and so we end up with a slope of 1/3 out of that. For a negative slope, so that's the red line, the red eyebrow in our diagram. So here now the line is going down from left to right. So our rise, quote unquote, is negative. We're going down 1 unit for every 3 units that we move across. So the run is still left to right, so that's positive, but it's the rise now that's negative because we're going down. And so that's why we end up with a negative slope in that circumstance. The mouth in this diagram here is our slope of 0 with the dimples on either side to remind us of that. And so we've got rise of 0. We have no vertical movement, but we've got a horizontal run of 3 or however far we want to go. It doesn't matter. If we have 0 in the numerator divided by anything, our answer is going to be 0. So that's why we end up with a slope of 0. So we have the horizontal line. And then finally, when a line is vertical, that means we have vertical movement. Again, we've indicated it here as being 3, but it could be just 1 unit from point to point or 4 units from point to point. But we have no sideways movement, so there's no run. And so in this case, we're dividing by 0. And so the symbol that we want to use for that, even though we have the U for undefined, that's just to line up with the nose on the diagram here. Really what we want to do if we run into a slope that's for a vertical line that's undefined, we want to use that 0 with a slash through it. That's the way that we want to describe an undefined slope. So again, this is just a little tool for us to be able to refer to kind of remind ourselves when the slope is positive, when it's negative, when it's 0, and when it's undefined. So now that we've reviewed the concept of slope, let's take a look at these 2 forms of the equation, slope-intercept form and point-slope form, that give us the slope just by looking at the equation, and then give us some information about where the line is located, whether that's with a y-intercept or some other point, that allows us to, instead of having to plug in numbers like we did in the general form to find the intercepts and sketch the graph, we can just look at the equation, get the information we need, and sketch our graph. So slope-intercept form is the first one. So number 1, we have to have y isolated in our equation. It has to be y equals, and then everything else is piled up on the other side. Second, the number that's multiplying the x is your slope. Now if that's a whole number, we just turn it into a fraction by putting it over 1. If it's a fraction, then we just use the numerator as the rise, the denominator as the run. If it's negative, that just means the rise is going to be negative, so it's going to be going down from left to right, but we're still going to move in that left to right direction. So that's the slope. And then any number that's being added or subtracted after that is going to be our y-intercept. So that's the number b in our equation. So again, if I know what the y-intercept is, then I know where the line travels through the y-axis. If I know what the slope is along with that, then I know how it moves from that point, and so then I can sketch my graph. And we'll see an example of that in just a moment. The other form is point slope form. So here, in principle, it's the same idea, where we have some information about the slope. So we can see here that the m is going to be the number that's multiplying information involving x. And then we've got a point that could be anywhere along the line. So instead of being the y-intercept, this point, the place where the graph crosses through the y-axis, this point could be anywhere along the length of the line. But given that, knowing a place that the line travels through along with the slope is what allows us to be able to sketch the graph without having to do any kind of mathematical work. And so we'll see an example in a moment of what this equation looks like. Kind of one key thing here is the coordinates of the point. So the number that's going to be subtracted from the y here and the number that's going to be subtracted from the x here, those two numbers show up in the equation as the opposite of the positive negative sign of the coordinates of the point. So if it says y minus 3, that y1 value, that coordinate is going to be positive 3. If it says x plus 2, then the x coordinate of that point is going to be negative 2. So whatever positive negative sign we see, it's going to be the opposite for that point x1, y1. And again, we'll see an example of that in just a moment. But first, let's take a look at an example of a line that's given to us in slope-intercept form. So right here, we've got our y is isolated, so it's y equals mx plus b. So we look at the number that's multiplying the x, it's negative 3/2, so that's going to be our slope. And again, I'm going to use that negative 3 as our rise, but the run will always be positive in this circumstance. So we're always going to move from left to right. It's just we're going to go down 3 units because of that slope. And the y-intercept in this case, the b, is 3. That's the number that's being added after the x piece of the equation. So if I go to our graph, I'm going to start with the y-intercept. That's the place I'm going to begin my graph because I have to know where my line is traveling, and then I can use the slope to figure out how it's going through that location. So I'm going to go to 3 on the y-axis. It's the y-intercept, the place the graph crosses through the y-line. And now I'm going to apply that slope. So I'm going to go down 3 units, but to the right 2. So I'm going to count down 3, to the right 2, not from the origin, but from that y-intercept point that I made right there. And I can repeat that a couple of times. I can go down 3 again, over 2, down 3 again, over 2. I can even go up 3 units, but then I would have to go backwards 2 units because I'd be positive in the vertical direction, but I need that negative slope, so I've got to go negative in the x direction in that case. Bottom line is we end up with a straight line that travels through all those points. And in our last example that we see here, now the equation is written in that point slope format. So it's y minus y1 equals m times x minus x1. So we want to kind of unpack this to get all the information that we need. So again, the slope is going to be the number that's out in front of the parentheses on the x side of the equation. So that's right here. It's the 2. So my slope is 2. I can write that as a fraction as 2 over 1 to help me with my rise and run. And then my point, the point that my line goes through, is going to be determined by the numbers that are being added or subtracted from the x and y. So if you'll recall earlier, I said that the coordinates of the point are the opposite of the positive negative sign that we see in the equation because it's x minus x1. Well, to turn that into a positive, that means that my point's x coordinate needs to be negative 7, and then for y minus 1, the opposite of the positive negative sign that I see there is 1, so that's going to be my y coordinate. So negative 7, comma 1. So that is the point that my line travels through. And so I'm going to start there. I'm going to begin with the point. So I'm going to go negative 7. So 1, 2, 3, 4, 5, 6, 7. And then I'm going to go up 1. So that's going to be the starting point of my graph. And then from there, I'm going to apply that slope of 2 over 1. So we go up 2 over 1, up 2 over 1, up 2 over 1. We can go down 2 from that first point, and whoops, don't want it there, and go back 1. And so here again, we've got our line that travels through those points, has a slope of 2, travels through that point, -7, 1 that we got from the equation, and then we just go from there. So again, with both of these, slope-intercept form and this point-slope form, we didn't have to do any mathematical work to get all the information that we needed from to be able to sketch the graph. We got it all from the equations. And so that's the advantage of having the equation written in one of these two formats, as opposed to standard form where we have a little bit of work that we have to do to get enough information to be able to piece together the graph.